The intermediate value theorem states if we have a function that's continuous over some closed interval, so for that part of the function, and the y values at the endpoints don't match each other, okay, so this y value here would be f of a. This one here would be f of b. So they don't match each other. There has to be some number, k, in between here and here that matches up with the x value that's in between the endpoints. Okay, think about that. If I'm going from A to B, and I'm going from one y value to another continuously, then if I pick a point in between them, the y value must be in between those y values, right? It's pretty obvious. Okay, so what do we do with this? Verify the intermediate value theorem applies to the function and find C. Find the x value where this occurs. Okay, so I've got the function f of x equals x squared plus x minus 1 on the interval 0 to 5. So that's my A and my B. And I'm saying find the value of C, or the value of x, that makes the function equal 11. Okay, so my k would be the 11. All right, but it's first asking me to verify that I can use this theorem. Well, that means I need to know what is f of a and what is f of b. And I've got to double check that k is in between them. Otherwise, I can't use this theorem. All right, so my a is 0, so f of 0, if I plug a 0 into this function, I'm just going to get -1. If we plug a 5 in, I'm going to get 5 squared is 25 plus 5 minus 1. That would be 29. So we're saying that there must be a y value in between those that is 11. Well, 11 is in between those, right? So that means I can use the intermediate value theorem. Now we just do the math. So we just verified that it applies. Now we do the math. So we're saying, when does this function equal 11? That's what we're really saying. For what x value does this function equal 11? Well, I got a quadratic here. To solve a quadratic, we factor. And to do that, we have to have one side equal to 0. So I'm going to subtract 11 from both sides, and I'm going to get a -12 on the right. Okay, so what multiplies to -12 and adds up to 1? +4, right, so we're adding up to a +1, and -3. So if we solve each of those factors, I get x equals -4 and 3. So we got two answers, two x values that make the function equal 11. Are they both valid answers for this problem?
It's an x squared, so it'd be a parabola.
It is an x squared and it's a parabola.
Only one of them fits into where it needs to.
Only one of them is contained in our domain. -4 would not be the answer for our specific interval going from 0 to 5. So we would just get 3, so we would say our C value is 3.